All right. So, by the way, have any of you ever read this book? This book series called the Game is the first one by Terry Schott. Super, super, super good if you're into sci-fi. It's like VR kind of worlds within worlds type thing. Pretty interesting. Highly recommend it. And there's like 10 or 12 books in the series. All right. So, homework for today to update the program to allow players to collect. Okay, so we're going to collect some pellets and stuff, and we're going to keep track of those pellets. And we need to have some way of showing them on the game screen uh, so that we know what total number of pellets we have. Now, one thing I kind of said at the end of last class was um, that we might use the pellets that we collect as a kind of a tool for making our guy a little tougher during fights later on or something like that. So um, when we think about how we want this pellet thing to show up, uh, one thing that some of you may have done is this is coming back to our original tutorial that we had looked at, but you maybe had done a canvas or something like that that showed the score or something along those lines. Well, I'm kind of thinking as our guy goes around the game, if you think about a lot of video games, they have some kind of like a health bar or something like that above the person. So maybe not necessarily do a health bar initially, um, uh, but have the number that is your current number of pellets you picked up, kind of over your dude's head at all times, so that you can see it. And then when you get in a fight, it counts down off of that or something like that. That's the extra armor you have before your hit points start going down. So the information is kind of right there rather than putting it on a canvas. Canvas is fine if that's the way you went about it, but let's look at this other approach. And then kind of the kicker here was when you pick up one of these pellets in a room, it should no longer show up in that room. So the room needs to know what pellets are currently available. All right. So again, we're still connecting stuff to our back end. All right. So a couple of things we want to keep track of here. Get into my We're definitely going to want to use our singleton to remember our total number of pellets. That way, it doesn't matter what scene we're in or whatever. Our singleton knows about that. We're also need to allow our room data structure behind the scenes, to know about the pellets that are currently in a room, right? And then make sure that we update when a pellet is collected. We update the room that a pellet in a certain location has been collected, because the next time we come back to this room, when the room loads, we already have the code in there to make sure we show the right exits of the room we're in, right? Because scenes, we have our scene set up as kind of throwaway. Whenever we present a scene on the screen, we say, okay, well, here's the scene. Now let me real quick close off the doors that aren't supposed to be open. And now we can do an additional thing of making sure we make the pellets that aren't supposed to be there disappear ahead of time, right? So now we're making our room remember a couple of different things, not only the exits that should be available in the room, but the pellets that are currently available. Now, did I say to do one on the way to each exit? Okay, so all available exits. Okay, so that's going to be even another challenge, right? So now when we place a pellet in the room, we want a pellet to be associated with each exit that is available in that room. So not every room would have 4 pellets. Some rooms would have 1 pellet. So our very first dungeon room only has a single exit, so there should only be a single pellet leading to the north. But if we come back to that room, that pellet should now be gone. Should be collected, right? So we're going to have to remember whether or not we visually show pellets or not inside of a room. So let's go and look at some code for that. Maybe what we would do is, as a starting point here, I'm going to go ahead and, well, I'll leave the pellet there. I Yes. So I'll go ahead and create our other 4 pellets. Something along those lines. So those are the 4 possible pellets we can have. I'm going to go ahead and create a empty game object in here. Call that guy pellets. And then I will take our 4 pellets. I'll just throw it in there. That way they're not taking up a whole big screen of things. So we're just using the empty game object as kind of a folder over there. All right. Now, one interesting thing, though, is I do have the ability now through a single game object to get rid of all the pellets. So if I had access to this pellets game object, which is the parent game object for these 4 other game objects, and I deactivate pellets, everything underneath it also deactivates. So we don't see them. May or may not be helpful for us here, but something to take into consideration. All right. So we go to our rooms here. Do I have a Visual Studio open? It's code. Let me open it from in here. All right, so inside of a room, we already have a collection of exits, up to 4 exits. And now we want to go ahead and we want to have a collection of pellets that are available. All right. Well, when do we deal with our exits? So let's go back and look at when I think it's our dungeon controller, right? So in our dungeon controller here, when one of our rooms first starts, when we load this scene, during the start of it, we grab the current room we're in and we start getting information about that room so we can turn exits on or off or whatever. So inside of this guy, whenever the current room has an exit to the north, we turn that exit, we turn the blockade for that exit off, all right, to let them go there. So this would also be an opportunity to do something similar to find out, should there be pellets in that direction, right? Have we already collected the pellet in that direction? All right. So inside of a room, we want to have come up with a mechanism for remembering the pellets that are in this room. All right. So as of right now, we only have one kind of pellet, right? Now, we might imagine that we end up having more than one kind of pellet, correct? Maybe we have some pellets that are worth 1 armor, some are worth 5 armor, some are worth 10 armor, whatever. Might have a superpower pellet that heals our guy 100%. Okay, so we could imagine having pellets of different kinds. So what I'm going to do is I'm going to go into I'll start with my normal class scripts here, and I'm going to create a file, create a C# script. It'll default to mono behavior, but we'll change that. And we're going to say that this guy is a pellet. All right. So we want to keep track of the nature of a pellet behind the scenes. All right. Now, the idea here is that, so we're kind of going back to our programming capabilities here, less about Unity. We might have the idea of a generic pellet, but generic pellets never actually exist on their own. You always have a pellet of a certain kind that ends up existing. So we either have a, what's called a light armor pellet, medium armor pellet, strong armor pellet. If we just leave it at that, where how much does it bolster your guy's strength or something? We haven't gotten to our dudes fighting each other yet. We're going to do that this week. But That's kind of the idea here. So we'll start off just having a generic pellet where it only helps, it raises our armor by 1 or something. But right now we're just keeping track of the pellets we've collected. But ultimately, we're going to be looking at using inheritance to create things that are pellets, but they're more powerful pellets, or they have special abilities off of our base pellet. So I'll go ahead and open this guy. Now, here's our example of inheritance here. So our class pellet inherits currently from mono behavior. Okay, what we might have in the future is something that is like our class power pellet inherits from pellet and then builds on top of that. So that might be a direction we're moving, but I'm just creating the foundation here for a generic pellet. Can anybody remind me in Java what we can do to a class to make it such that we can't create instances of that class? The only reason the class exists is to support inheritance. And remember the key word. What can we make a class so that it's illegal to create instances of it? Go ahead. Protected has to do with our fields, and so public-private protected is where we have access to something. I'm talking about a keyword that effectively locks a class down, and you can't actually create instances of that class. I think our inhabitant class last semester was one of these dudes. Anybody remember what our special kind of keyword we can put in front of the class? It would go right here. Remember the abstract keyword? We definitely looked at it at some point. So abstract keyword, we had this idea last semester when we were creating inhabitants in our game. This was when we were into the Java part of it, so the last 6 weeks of class or so. We never would actually have a generic inhabitant. Inhabitants were always either players or monsters. So we had a player that extended inhabitant. We had a monster that extended inhabitant. Well, the idea there would be is we can just, as a programmer, choose to never actually create an instance of inhabitant. Or we can police it by making that class abstract. So just to throw this back into the notes. Abstract keyword denotes a class that cannot be instantiated directly. Typically used to create a class that exists for the purpose of inheritance. All right, that is to say, we're never going to actually create, in our previous example, we'll never create an inhabitant. Instead, we would always be creating players or monsters. In this case, we're always going to be, well, not my current setup, but eventually we're always going to be, well, actually, I guess we can do it. It's not going to cost us very much. So we're going to have this class called pellet. We're going to make the class abstract, which means we're never actually going to create a generic pellet. We're always going to have pellets of certain kinds, certain abilities, or something like that. All right. We can go ahead and have the constructor for our pellet class. And, we can decide, well, what does a pellet class have in it? Well, maybe we decide that a pellet is going to have a, maybe an int bonus, something like that. And then what we do is we take the bonus in as a parameter, and we'll say this dot bonus is equal to bonus. So here's our class pellet that is abstract. It has a single field that's private. What does it mean for a field to be private? What can you tell me about this variable bonus based on it being private here? But yeah, we can only access it inside of this class. Now, realistically, we are probably going to be accessing it, or at least potentially accessing it outside this class, potentially one of the children of this class. Because right now, I'll go ahead and create our child class as we're kind of building this. I'm going to create another class in here. And why don't we call this guy an armor pellet? All right. And an armor pellet is not a mono behavior. Instead, he's a pellet. And then we'll have our constructor for armor pellet. And for right now, let's just assume that all armor pellets just give a single armor, single bonus, something like that. All right. So what we would do is we would say, let's see, how do we get to my parents' class? I think it is it just pellet? Give me a moment. Calling parent constructor C#. So we've already seen, oh, it's just the word base. That's right. Weird syntax. All right. So in Java, if we were writing this, pellet would still be abstract. So the abstract class means the same thing in Java as it does in C#. In Java, if we wanted to call our parents constructor, we would do it on the very first line of our constructor here. And we would just say, okay, when we create an armor pellet, we're going to go ahead and create a normal pellet, passing in a 1 as its bonus, so that we actually are storing that information inside of our instance of pellet. Remember that classes exist in a hierarchy, right? When we first started looking at objects, we saw this example of all objects in all of our object-oriented languages inherit from a top-level object called object. In Java, it's a capital O. In C#, it's a lowercase o for their top-level object, which is kind of funny since I've advertised that generally speaking, class names are almost always capitalized. That is a naming convention across most languages. So it is kind of funky that Microsoft has their object named with a lowercase o. Whether it was just bad programming, I would say probably not. One theory might be that they're treating an object as kind of the special type thing, almost like a primitive type. So they just purposely make it all lowercase as an example of this guy is kind of this special thing. He's not just a normal plain Jane class. That's one possibility. Another more nefarious possibility is, if you remember our story from last semester, the way that C# even came into existence is through a lawsuit between Microsoft and Sun Microsystems, who later Oracle purchased Sun Microsystems. But Microsoft tried to steal Java, so they had their own language called J#. They got sued by Sun Microsystems, which kind of forced them to create their own brand new language. It's called C#. So perhaps making string a lowercase s instead of a capital S and making object a lowercase o instead of a capital O was part of what Microsoft was doing to prove they were differentiating themselves from Java. At the end of the day, I'm not sure it matters, but whatever. Okay, so in our example here, we have pellet. Okay, so this object class, this is something we cannot touch. This is built into the programming language, right? No matter what the object-oriented language is, they're going to have a class-like object at the very top level. This is how object-oriented languages are built. Now, we've written this pellet class, but we've set it up to be abstract. So we're just going to yellow code this and say if a class is yellow, That means it's abstract. That means we'll never actually create a generic one of these. He exists to support inheritance. So now we have this idea of an armor pellet. And this guy will be the normal class that inherits from pellet. So pellet is our base class for armor pellet, whereas object is our base class for pellet. So all pellets are objects. All armor pellets are also objects, but they're objects by way of pellet. Okay, so this is the hierarchy that object-oriented languages follow. So this is kind of what we're trying to build here, is this this type of hierarchy. And so in Java, the very first line of our constructor in the child class, so this is armor pellet. In Java, we would say extends pellet. That's our word for inheritance in Java, is extends. In C#, it's just a colon. C++, it's a 2 colons, if you remember that guy. So, you know, they get very imaginative here. In Java, calling your parents constructor, it just has to be the very first line of your constructor here. Now we can make an argument. We can say, well, we like this better than this syntax up here. But I would programmatically argue that the syntax up here is actually probably the better syntax. It's the more uncomfortable syntax, perhaps, but it's the better syntax, since the rule in Java that is that if you're going to call your parents constructor, it has to be the very first line of this constructor here. Nothing prevents you from making it the third line, except a compile error. Make sense? So it sort of kind of makes sense that if we are going to first create an instance of our parent before we differentiate ourselves, then we should always create the instance of our parent first and then differentiate ourselves. So it makes sense to pull that syntax up into the header for our constructor. So we have no option but to have it happen first, because it happens before we even get to the body of the constructor. Make some sense? So rationale for why this maybe makes reasonable sense. Now, calling the parent class the base class as opposed to calling it pellet. Well, clearly it's coded blue, so that's a keyword inside the language. I'm not sure I like that or not like that. It's maybe a toss-up. Since we can always reference up here who the parent of this guy is, we're not losing track of that connection. So we call it pellet here, and then from that point forward, base is kind of a placeholder for pellet. I guess that's okay. But whatever. So when we get to this first line here, what we're dealing with is we already have our instance of pellet. Now, notice here inside of my little note here, abstract means it's a class that cannot be instantiated directly. That doesn't mean we can't have instances of it. It just means you can't directly create an instance of it. That means we can't come in here and say something like pellet P is equal to new. Yeah. All right, we can't do that. Okay, it says cannot create an instance of the abstract type or interface called pellet. We're not allowed to directly create an instance. Okay, but we do have an instance of this guy from our base here. So is it called super or is it called base? So this would be base dot, well, I got to loosen it up first. So if we go into pellet, right now we've made bonus private. Okay, and he mentioned that private means we can only access this variable if we are inside of a class called pellet. Where right now, if I'm out here, I'm in a class called armor pellet. I can't access it directly. So what we can do is we can come in here and we can just loosen up the security a little bit, make this guy protected, which now will make it accessible by our children of the pellet class. So there is our variable called bonus that we have in there. So we would have access to it. All right. So one note we can make here if we want to put it into the notes is that base in C# is equal to super in Java. Something along those lines. Both languages use this to point to an instance of the current class. In C#, they use a keyword called base instead of a keyword called super. Starting to feel more like a way they were trying to differentiate themselves in terms of the language. It's fine. All right. So what we're saying here is we want to, whoever our parent is, access their field called bonus, which we do have access to since we made it protected, and this guy is a child of that class. And then we can do whatever we want with this guy. So maybe what we do is we say that whatever the bonus is, it's multiplied by 2 for no good reason. Now, we certainly could have just put next to armor pellet here that instead of a base of 1, we can just say, cast it a 2 there and been done with it. But just kind of forcing the communication between these guys. When we build an armor pellet, we first build a pellet that has a bonus of 1, and then we differentiate our armor pellet from a normal pellet by taking whatever the bonus currently is and doubling it. For no good reason. Except this is the way you can pull it off. All right. So I'll just say differentiate our armor pellet from a normal pellet. You can do whatever that means for you. Now, one thing we could do if you want to force this issue is inside pellet, we might decide, well, all pellets really should have a name. They kind of have a name that might show up for the type of thing. So maybe we do something like a protected string name. And the name for a normal pellet is maybe pellet, like that. So when we first build a pellet, we pass in whatever the bonus is. We store the bonus, but we also say the name is hard-coded to pellet because all pellets will be named pellet. Now, what we could do is inside here, instead of updating the bonus, we could say something like base.name is equal to armor pellet. So we made a modification there. Or we can do something like base.name is equal to whatever base.name currently is, concatenated with maybe a colon concatenated with the string armor pellet, something like that. So generic pellets are just called pellets. Armor pellets are pellet, colon, armor pellet. So we've differentiated our armor pellet from a normal pellet here. All right, so this is all happening behind the scenes. This is all of our data structure stuff at this point. So we haven't actually put these things into use. We've just invented a couple of variables. We invented a generic variable called pellet that's meant to create instances of, and we've created our first special kind of pellet, call it armor pellet, that updates his name slightly. All right, so now we go back to a room. And now rooms are going to have some number of pellets in them. Now, the number of pellets that are in a room is going to equal the number of exits in a room if we're going to have pellets on the way to each exit. All right. So now we have to decide, well, how do we represent our pellets in here? Now, would it be possible, let's assume we fast forward a little bit and say that we have three different kinds of pellets. You know, we got an armor pellet, we got I don't know, a fire pellet and a water pellet or something like that. And each of them does something different in our fighting. Gives us different, maybe one makes us tougher, one adds fire damage to all of our attacks, one adds water damage to all of our attacks, something like that. And let's assume that in our rooms, we randomly determine which kind of pellet will arrive in that room. This is something we might be adding into this, okay? That means each room can have a maximum of 4 pellets in it, right? Assuming it has 4 available exits, like our whatever it was, room 3. I think room 3 is our center cog in the top of our cross. So room 3 has 4 open exits. So originally it would have 4 pellets, and maybe those pellets can come in a couple of different flavors, whatever that ultimately means. All right, so a room will only have as many pellets as it has exits. But we also need to know where those pellets are located for the purpose of making them disappear when they've already been collected. All right. So what we're going to do is we need to keep track of our potential pellets. So inside of room here, I'm just going to hard code 4 pellets instead of putting them in an array or something like that. This will keep them clearly as the north pellet, the south pellet, the west, the east pellet. Now, since a pellet, I fast forwarded a little bit. I said we're going to have an armor pellet, a fire pellet, and a water pellet. Since any pellet can be one of those 3, how do we know which class to use to hold our pellet for north? So when we say, here, we'll put the type like that. When we say north pellet, and this guy would originally start off as null, what kind of value should go here if we don't know if it's going to be an armor pellet, a fire pellet, or a water pellet? Is there a way that we can talk about water, fire, or armor pellets completely generically? All armor, fire, water pellets are all what? They're all normal pellets, right? We can even go a step further and say they're all objects as well. All right. But since we know this guy's going to follow the rules of a pellet, we're going to say that we're going to have a private pellet called the north pellet. Have our south pellet, east pellet, west pellet. All right. But now wait, pellets are abstract, which means we can't create instances of them directly. Is this guy an instance of a pellet? So first of all, we might say, well, this is clearly allowed because there's no red squiggles, right? So we obviously understand why it's okay. So we'll just move on with life. All right. Pellet is abstract. We are not allowed to directly create instances of pellet. What is north pellet? Tell me everything you know about north pellet right now. First of all, is north pellet an instance of pellet? It's an important concept to understand. This is another one of those. We probably have more than 5 in our top 5, but in order to leverage modern programming languages, we need to be able to identify something in the wild when we see it. So if we're putting this rule in place that we can't create instances of things that are abstract, we need to know what's an instance and what's not an instance, right? What can you tell me about north pellet here? Give you a multiple choice. Is it a cat, dog, or variable? All right, so this guy's a variable, right? What are variables? little buckets meant for holding things, right? So north pellet is a variable. Now, we are in a language, C#, which is like Java, which is like C, which is like C++. These are strongly typed languages. What does it mean for a language to be strongly typed? And just go ahead.
It creates all the space for the variables ahead of time.
Okay. So it gives us enough space to hold the kind of thing we're holding. Okay. It also polices us, right? If we build a variable capable of holding an int, that variable now knows how to hold ints. Can't put a string in there, right? Loosely typed languages allow us to just create variables and then put whatever we want in there. And then it just kind of adapts, right? Whereas strongly typed languages, like most of our compiled languages, are strongly typed languages. They require us to specify what kind of value a variable is built to hold. So north pellet here is a container for holding a value. What kind of value? A pellet. So what kind of thing would go inside of this variable? What would live inside this variable would be an instance of pellet. That's the kind of thing that would be inside of the crate. Okay. So I have this little bucket here called North Pellet. And if it did right now, I just got home from who sells the container? Home Depot. Yeah, I got home from Home Depot with my big container. Okay. It's empty though. I haven't put anything in there yet. That's why I set the value to null. Okay. So it's an empty container, but I expect that once it's filled, if somebody tells me that guy has something in it, I know the thing that's in it is an instance of pellet, right? So we haven't broken any rules here yet. All right. Abstract is still protected. We have not created an instance. We have not directly created an instance of pellet. We're about to indirectly create instances of pellets by creating instances of armor pellets, right? Because an armor pellet is a pellet. But an armor pellet is not abstract. So we are allowed to create instances of armor pellets. We're just not allowed to create instances of pellets directly. All right. So back inside room here, we have the potential for holding 4 different pellets. Now, what we need to do is we need to keep track of what pellets actually exist. So when this room is first born, okay, we create our instance of room. And this room is setting its name. It's setting its current player initially to null. We could set our north, south, east, and west pellets all to null down in here as well, instead of defaulting them to it. It's their default value anyways, but we're just going to leave it alone. We can add a player. We can remove a player. We might want to have the ability to add a pellet to a room. Is that you? I think we're right above the loading dock in this room. I think that's what's right below us is the loading dock. I think so. Maybe that's that room. So we might be right above outside right now. The loading dock. So there's like a semi underneath us. All right. So we might want to have the ability to add or remove a pellet from this room. All right. So let's go ahead and let's give the ability. We'll say public void add pellet. And this guy will take in a pellet of some kind. All right. We don't know what kind of pellet. Well, right now we only have one kind of pellet, but I've foreshadowed and let you know we're going to have fire and water pellets. So somebody's going to have to be in charge of reminding that that's the pellets I invented next class. All right. So we're going to have the ability of adding a pellet of some kind to this room, and we can accomplish that through the generic pellet class. Again, this guy is not an instance of pellet. He is a variable that will hold an instance of pellet of some kind. Okay, but he's not an instance of pellet himself. Now we probably also need to take in a string direction here. I'm not sure this is the cleanest way of doing it, but we'll just do it this way anyways for the sake of time, where we're going to say, I want to add a pellet to the north, or I want to add a pellet to the south, so on and so forth. So we'll say if direction dot equals north, then this dot north pellet is equal to P. Else, if it's south, or south pellet, east will be our east pellet, west will be our west pellet. Otherwise, we just won't set any pellets. They pass me the direction LOL. We're not going to put that pellet anywhere. We'll just let it drift off into oblivion. All right. We can always, if we want to have a little error message, we can always do something like an else. What's it? Debug.log. Not a valid pellet direction. Something like that. All right, just to give us a little feedback in case we write our code and we start passing in uppercase norths or something, or misspell a direction, we'll get a little, we're wondering why pellets aren't showing up on our screen. This will give us some feedback. All right, so this is how we add a pellet to a room. Similarly, we want to remove a pellet from a room, probably at the time that we collide with the trigger for our pellet. When we actually hit the pellet, we collect it, we probably want to then remove it from our data structure. So we don't tell it the pellet we want to remove, we just tell it the direction. If the direction was north, we will set north pellet to null. It's the south, south pellet to null. East, east pellet to null. West, west pellet to null. All right. So we've taught rooms how to add pellets and how to remove pellets, given a direction. All right. So now when a room is being born, we have to now decide, should a pellet be in this room or not? So let's go to our dungeon controller. All right. So in our dungeon controller, this is where we're going through. We're getting the current room, current instance of room. So rooms are only built once. An instance of room, the thing that's holding our data about a room behind the scene, they only get created once. And then we grab them whenever we're generating our scene. Our scenes, every single time we come back to room R1, we're getting a fresh new scene. We're just kind of organizing it to look like room R1, right? Based on the data we're storing behind the scenes. So we'll go ahead and get our current room. We ask our room, hey, is there an exit to the north? If yes, we potentially should have a pellet to the north, right? We don't know if that pellet should still go there because we may have previously collected it. So we want to be able to ask, should there be a pellet here, right? So the way we might do that is go back into room and do something pretty similar here. Maybe call this guy has pellet and maybe have it return a Boolean. And then we will ask the question, if direction equals north, we will return. This guy should return true when north pellet is not equal to null. That means there is a pellet in that direction. So will return whatever this dot north pellet not equal to null boils down to. If this dot north pellet is currently null, meaning there's not a pellet there, is it true that null is not equal to null? Or are they the same value? They're the same value. So null not equal to null boils down to a false. But if I have some instance of pellet and I'm comparing that against the null value, is it true that an instance of pellet is not equal to null? That is true. So we'll return a true here. So we would do the same thing with our other guys here. I'm going to go ahead and just create an error. Create a little error message there for me that will allow me to pick up here because my scripts won't my scripts won't compile until that error is fixed. All right, so we'll stop here for now. Next class, we'll finish adding our pellets in a object-oriented way, and then we want to start trending towards getting our players maybe being able to get into fights or something, which is going to cause us to have to create another scene, a different kind of scene, the fight scene. Have you ever played the old original Final Fantasy games? As you're walking around or something, and all of a sudden you get into a fight, it shows a brand new view. That is your guys fighting. It's got your dudes over on the right, and then the monsters on the left, and the dudes step forward when they're doing their awesome, amazing attack, and yada, yada, yada. So we'll have something along those lines. All right, questions, comments, concerns, bribes? All right, no homework for Wednesday.